Sorry for that. You are not recording the session, but I believe we'll be able to understand what is going on. So if you look at this, if you look at these three papers, that is April 2023, they are testing regression concept. So having looked at this, you work as the management accountant for Majani Limited, which deals in tea production and export. Before embarking on next year's budgeting, you are tasked with analysis part or analyzing past revenue and price trends. As a starting point, your supervisor has provided you with historical price and production data as shown in the worksheet. So this is the worksheet. This is the worksheet. We have it here. We have it here. We have date, production in millions, kgs, and then price per kg. So after doing that, what do they want us to do? Plot a line graph for price against time stroke dates. Price against time stroke dates. So you have price against date. What do we have here? You're basically required to draw. This is April 2023. This is April 2023. Sasa mtu ameweka video. Huyu ni nani? Wacha tumsaidie. Good. So I believe that video should be taken care of here. Good. So we are being told to come up with a plot a line graph. They are specific plot a line graph of price against time. Price. So whatever is coming first against, that price will be in the y-axis. And then time stroke date will be in the x-axis. Will be in the x-axis. Then using a suitable Microsoft Excel function, show that the coefficients shown in the trend line in A above are in fact a result of a linear estimation between the historical prices and time. They basically want you to give us cost function in the form of y equal to A plus bx. That's what they want you to do. That's what they want you to do. Then you know that prices are affected by production. Because of this, you'd like to run a regression between price, production, and time. So you are comparing three items, which means you have two independent variables. You are now coming up with a cost function in the form of y equal to A plus bx1 plus cx2, whereby A, B, and C will be coefficients, right? So you're going to have coefficients A, B, and C. But remember A represent the fixed cost, B represent the slope of the curve. So we'll be having the slope of the curve. So we have variable x1, variable x2. x1 and x2 are independent variables. So that's what they want us to do in part 4 of this particular question. Be sure to discuss the coefficients and parameters. So that is what we are going to do. We have actually 3 methods of arriving at what they want us to do here. 3 methods of what they want us to, arriving at what they want us to do here. Now, if you look at August, they are testing management accounting, but now under break-even point analysis. But I want us to focus on regression. So once we are done with the regression part, we should be able to tackle December 2022, December 2023, and of course, April 2023, and of course, April 2023. So I want us to just have a new worksheet here. Our question of discussion today will be April 2023. But before we look at now the exact question, are we able to come up with some data set here? I want us to maximize the worksheet fonts. Okay, let me make it to be 12%. I hope hapo iko sawa. So let's have this. We want to look at units. Actually, we want to look at labor hours. We want to look at labor hours. We want to look at labor hours and total labor cost or total cost. So total cost here, labor hours and total cost. So there's that fixed component. There's that fixed component. For example, if you're working in a manufacturing company, there are those people who are full-time employees, and of course there are other people who are being paid based on the quantity of output. So the full-time employees, their salary will be fixed. Their salary will be fixed, while those people whose salary is based on the unit of output, we have to look at the quantity which was produced, and then we compare or we multiply by the labor rate per unit or per hour, right? Now, if you look at this data set here, I want us to come with some information. I want us to come up with some information that is labor hours. Labor hours here, we can have 34. We can have 38. We can have 43. We can have 51. We can have 23. We can have 18. And of course, we have 29. So let's just have those few data sample there. Then in terms of total cost here will be having 5,000. We'll be having 7,340. We'll be having another 51 here. And then we should be having 49 somewhere. 49. You can take this as 49. But now this 49 is corresponding to 51 is corresponding to 6,000. And then we have 8,600. Let's have those figures. 5,400. Let's have these figures. 2,400. 2,200. Then another 51. We have 5,900. 5,900. Good. So that is what we have. So let's have these figures. I would like us to have the same figures for some reason. Let's all of us copy this. I want you to copy this one here. I have a reason for that. So for today, we'll be forced to have the same figure. So just check your time, copy these figures to your working space. Then we see what we're supposed to do. Please do that within 2 minutes, and then we proceed. Do that within 2 minutes, then we proceed. Do that within 2 minutes, then we proceed. Okay, I believe you've been able to do that. I believe you've been able to do that. I believe you've been able to do that. Good. So if you now look at what we are having here, we first of all need to understand some terms here. We want to do what we call estimation of costs. We want to estimate costs. So let's say this one maybe is performance for the month of January, February, or week 1, week 2, week 3, or year 1, year 2, year 3, all the way to this part here. Now, you want to give us the number of observations. From this, you'll be able to get the average. You'll be able to get the average. And of course, from the average, you can now tell us, you can now project the cost, the total cost in the next period of production, given the total labor hours. If you're given total labor hours, you'll be able to estimate the total cost. So you have to look at the average. And that's all about regression. That's all about regression. Good. What you need to understand here, for us to come up with a cost function of two variables, whereby we have one dependent variable and one independent variable, that appears to be complex. For us to simplify this, I'll ask you a very simple question. If you want to look at the total cost you are going to incur, you'll be looking at the labor hours and the amount you'll be paying for the labor hours. Or if you want to know the labor hours, you look at the amount incurred. Which one depends on the other? Which one depends on the other? Do you arrive at labor hours by determining total cost, or you arrive at total cost by looking at the total labor hours? Cost will be depending on your cost will be depending on the labor hours, right? Assume this one here is kilometers covered, and this one here is cost of fuel. So the fuel that has been consumed will be depending on the kilometers that have actually been covered, right? Will be depending on the kilometers covered. If I want to look at the canteen expenses, let's say this is canteen expenses, I'll be considering number of employees, right? I'll be considering number of employees. So canteen expenses will be depending on the number of employees. Production cost will be depending on the machine. Will be depending on the units produced. Will be depending on the units produced. Repair and maintenance cost will be depending on hours taken to do this particular repair, or the frequency of doing this repair. So anytime they come to do a repair, of course, they are charging a given amount. So it'll be depending on the hours taken to do the repairs, or number of repairs that are actually done, or number of machine runs, because anytime you're going to run the machine, you need to do some repair and checkup, and therefore that will be used to arrive at the total repair and maintenance cost. If you want to look at maybe the cost of running online classes, we look at, we have labor cost, and then we compare that against number of lessons or class hours. If it is just done based on number of lessons without looking at the hours, then you're going to look at the number of lessons, right? If we are considering hours, like maybe payment are done based on hours, then you look at the hours, right? So you come here and look at the number of number of lessons done. So once you get the number of lessons, you'll be able to get total lecturing cost. But then you will also get to understand inside this lecturing cost or the labor cost, we have that fixed element. Let's say you are going to pay for the Zoom, right? The Zoom subscription here. You are going to pay a fixed amount for even maybe the entire month, irrespective of the number of students who will be joining that class, irrespective of the number of meetings you're going to conduct within that particular month. So long as you've been able to do the subscription for the entire month, the number of meetings will not matter, right? And therefore, that is a fixed component. But then all of them are being incurred towards ensuring that classes are conducted virtually. So those are the fixed components that have been combined. There's that other component whereby you are going to pay every lecturer based on the number of hours that they have been able to conduct a class. So that one will be dependent on the number of hours, and therefore it is the variable part of our total labor cost. So back to hours here, and of course total labor cost. Now, having identified that we have been able to know the variable item and the dependent and the independent item. So here we are going to do our illustration using one variable that is dependent and another variable which is independent. So our cost function will be in the form of y equal to a plus bx, whereby y here we call it dependent variable. So y will be dependent variable. X, we call it independent. It determines the outcome. Independent variable. It determines what the outcome will be, right? That is X. X here, we also call it cost driver. We also call it cost driver. We also call it activity. We also call it activity level. We also call it activity. We also call it activity level. So once we get the value of X, it will determine what our total cost is going to be. It will determine what Y will be, right? So Y here, the dependent variable, we also call it total cost. We also call it total costs. We also call it total cost. Then we have A. This A is the intercept. So if you're told to give us the intercept, A is the intercept. We are going to call it fixed. We're going to call it fixed cost. We are going to call it fixed cost. So this one here will be incurred whether we have zero activity level, whether you've produced 0 units, you must pay rent. Whether you've produced 0 units, you have to pay production manager. Whether you've produced 0 units, you must pay for premiums that has been used to ensure the production process, the factory. So you have to pay that. You must pay trading license. So such kind of things are going to fall under the fixed cost, intercept or fixed cost. Why are we calling it intercept? At Y intercept, X is equal to 0. At Y intercept, X is equal to 0. When X is equal to 0, and we said X is the cost driver, X is the activity level. At Y intercept, X is equal to 0, and the value of Y will be equivalent to the value of X. The value of Y will be equivalent to the value of X at this particular point. B here, we call it B here, we call it slope. We call it gradient. We call it gradient of the curve. And of course, this is now the variable. This is now the variable cost per unit. The variable cost per unit. So by just looking at this simple explanation, have you been able to see some of the questions that were requested in December 2022? They wanted you to give us the total fixed cost and of course the variable cost per unit. The variable cost per unit. So by doing this, we'll be able to, by doing this simple summary, we'll be able to get the cost function. So our cost function, of course, we are able to see it is y equal to a plus bx. Y equal to a plus bx. Good. Now, we have two ways of coming up with this cost function. Actually, more than two. One, you can use what we call accounts analysis method to come up with the cost function. Accounts analysis method. You can use what we call scatter graph method. Scattered graph method. You can use what we call regression method. You can use what we call ILO method. You can use what we call ILO method. So out of this, I believe you're able to cover this at your intermediate level. So accounts analysis and scattered graph method can be used to solve the cost function. So this one here, they did not include it in the course outline, but a question was tested requesting you to actually use this indirectly. They were telling you to use scattered graph method indirectly. So accounts analysis method, we are not going to apply that in BDA. Scattered graph, they are telling you to use it, but indirect. They will not mention the word scattered graph, but the question will be given in a way that you only have the option of using the scattered graph method. Then regression method, that one they have to come clear and indicate some of the specifications. And of course, ILO method. So I want us first of all to use ILO method. So long as I want us to use the ILO method for us to be able to solve that. Okay, so that is what we that is what we have. That is what we have. Now, are we able to use the ILO method to come up with this? Then the next thing, something that I did not explain at this particular point, slope, gradient, or variable cost per unit. How do we get it? It is change in Y. It is change in Y divided by change in X. 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 Can they repeat on intercept? Intercept at that point. So let me just draw something here. Will it be okay? We are going to draw it here and then you'll be able to see. When you come up with the cost function, at that point, when you have already incurred some cost, but you've produced 0 units. For example, here, I have 0 units. And my cost here is 200, right? My cost is 200. So this 200 is the intercept. When X is 0, I've produced 0 units, X is 0. This X, we say this is the activity level. The total hours taken will determine what our labor cost is going to be, right? Now, is going to be. Now, having identified those two, I want you to give me now, in terms of X and Y, what will we use to replace hours here? Will we use X or Y? Will we use X or Y? Which one will be used to replace hours? Which one will be used to replace hours? Which one? X, because X is the activity, X is the activity level. It determines what you are going to have as the value of, as the total labor cost. So the total labor cost is Y. This one here is the dependent variable. So when activity level is 0, the value of Y is the total fixed cost. And that's what we call y-intercept. When x is 0, when that line is crossing the y-axis at 0 units, at 0 activity level, what will be the value of y? That becomes the total fixed cost. Good. Now, I want us to rush very fast and use ILO method. I want us to rush very fast and use ILO method to come up with the cost function in the form of y equal to, in the form of y. Which year is this? The question we are going to tackle is April 2023, question number 22. But before we get to question number 22, we are trying to lay a background of what we are going to do. So this one here is not coming from any sitting. You just open an empty worksheet and have these figures indicated down there. Tuko sawa? Are we together up to that point? Are we together, Alex? Are we together, Alex? Good. So ILO method, you have to pick 2 points. You have to pick 2 points. Coordinates, when I'm going to pick 2 points, remember, for example, I want to pick point G, I'll be picking the coordinates that is x, comma, y. I'll be picking x, comma, y. And then I pick another point, point T, I'll be picking the value of x, comma, y. I'll be picking the value of x, comma, y. But now the formula we are going to use, which is ILO method here, ILO method, you pick the highest value. As the name reads, you pick the highest values pair and the lowest values pair. When you're going to pick the lowest value, assume that you don't have the dependent variable. Go to the independent variable column. Independent variable column. So are we able to identify our independent variable column? Independent variable column is this column of x values. This column of x values. Now, having done that, at any given time, you're going to solve a question using ILO method. Go to the independent values column. Look at the highest value and the lowest value. Don't consider whether it is corresponding or not corresponding to the highest value in the y column or the dependent values column. So here, for example, we want to pick now, we want to pick the highest value. So let's say G will be the highest value. So what are the coordinates at point G? Coordinates at point G, the highest value. Which one will we have? The highest value you can see we have 51, right? Now that we have 51, and there are 2 of them, are we having the same figure against that 51, which is the highest value in X column? The answer is no. The answer is no. So 51 here corresponds to 5,900. 51 corresponds to 6,000. So when you have the same value in column X, and it is the highest value or the lowest value, it is only under that circumstance that you now move to column Y and look at the highest value, which is corresponding to that, right? So I have 51 as the highest. Let me look at the first 51 is against 6,000. This one is against 5,900. So if I need the highest values pair, it will be 51, 6,000. Then you close your bracket. How about the lowest values pair? The lowest values pair. The lowest values, I'll still come to column X and look for the lowest value. Right? My lowest value here, as you can see, it is 18, right? 18, as you can see, it is corresponding to 2,400. But if you're keen enough, you'll be able to see the lowest value in column Y is not 2,400. It is 2,200. So imagine somebody somewhere or somebody in this meeting will be taking 29, 2,200 to be the lowest values pair because 2200 is the lowest value in column Y. Of course, they are right. Right? They are right. 2200 is the lowest value in column Y. But we said, yes, it is the lowest value in column Y. But whatever will be guiding you is the independent variable column. The independent variable column. The highest value and the lowest value will be considered from which column? Column X, the independent values column. So it means it will not be 29, 2200. It will be 18, since 18 is the lowest in column X, comma, the amount corresponding to it, 2400. Then you close the bracket. So we've been able to pick the pairs of the highest value and the lowest value. So once that is done, you come and start by giving us the slope. The first thing that you can calculate in our cost function of y equal to a plus bx is a. I mean, is the slope of the curve, which is b, is the slope of the curve. So let's come and calculate the slope of the curve. How do we get the slope? Under my explanation here, I said it is change in y over change in x. What does g and t stand for? These are the names of the coordinates, the point. You can even use h to represent highest value. You can even use L to represent the lowest value. So these are just letters that we decided to use. So change in y, how do we get slope of the curve? Equal to, close the bracket, change in y. So change in y, the first value of y is 6,000 minus 2,400. That you divide by 51 minus 18. 51 minus 18. Then you close your bracket. If that is done, we are getting this as the value of B. We are getting this as the value of B. So it should be to 4 decimal places at least. Good. So this B is the slope of the curve, is the gradient of the curve. So this one here is what we call the variable cost per unit. This is the variable cost per unit. What if we take this 51.59? 51.59. Good. As the highest value. Fran? Is that what we are referring to? Is that what we are referring to? Remember, we are looking for the highest values pair. And whatever is guiding us is column X. It happened that we have 51 appearing twice. Now, if 51 is appearing twice, which one is the highest value? The highest values pair is X, Y. So if X, we have two values of X being 51 and 51. So the corresponding values will be considered. We'll be looking for the highest value. So which one is it? Between 6,000 and 5,900, which one is the highest? Which one is the highest? 600. So that's why we are picking this pair, not 5,900. Ukitumia 5,900, hiyo ni 0. Ukitumia 5,900, hiyo watakuwekea 0. Good. Can you repeat the value of B? What did we say when we were explaining the value of B hapa? Tulisema B is the slope, stroke gradient, stroke variable cost per unit. And what did we say? It is change in Y over change in X. Change in Y, the difference. We are talking about the change in Y. So change in Y, we are talking about the first value of Y, the highest value is 6,000, right? Minus the lowest value of Y is 2,400. So that change, what is the change? Between 6,000 and 2,400, what is the change? The difference, 3,600, right? So that is Y, that is change in Y. Then let's look at the change in X. Change in X, itakuwa ngapi? You follow the same pattern. We started with the 600. So the value of X at that point is 51, right? Minus the value of X under the lowest values pair is 18. When that is done, we are getting 33. So what is the formula? Change in Y over change in X. If that is done, we are getting 1.0909. So is it clear to somebody now? Is it clear to somebody now? Is it clear to somebody now? Irene, confirm. Emily, confirm. Good. That's how we are getting the value of B. So look at our cost function. Our cost function is Y equal to A plus BX. Y equal to A plus BX. Do we have any? So you can pick any of the pairs, either the lowest values pair or the highest values pair. So let's say we've decided to pick the lowest values, the highest values pair. The highest values pair. And our cost function is in the form of Y equal to A plus BX. So do we have any of them? Let's pick the highest values pair. So what is the value of Y? What is the value of Y? The value of Y is 6,000, right? So you are telling us here that 6,000 is equal to A. Do we have A? No, we don't have A. Plus BX. Do we have B? Do we have B? Yes, we have B, 109.0909. We multiply by X. X is the activity level. Do we have activity level? From column X, we have activity level. So when the value of Y is 6,000, what is the value of X? What will be the value of X? To Konai Upper, we've decided to pick the highest values pair. So when Y is 6,000, X is 51. And we are saying it is BX. That is B times 51. If you look at our equation here, we've been able to eliminate everything and we only have one unknown. So let's make A the subject of the formula. So when you make A the subject of the formula, you'll be having 6,000. You'll be having 6,000 minus, close the bracket, 109.0909. We multiply by 51. When you make A the subject of the formula and then you work out that, what is the value of A? What are you getting as the value of A? What are we getting as the value of A? What are we getting as the value of A? What are we getting as the value of A? The value of A. So the value of A is 436.3641. Having done that, are we able to come up with the cost function? Y equal to our fixed cost. So the fixed cost is the value of A, 436.3641, right? Plus variable cost per unit, which is 109.0909 X. This is the cost function. So should they tell you that in the next period, in the next week, in the next month, in the next year, they utilized 56 labor hours. They utilized 56 labor hours. Are you able to estimate the total cost? Are we able to estimate total cost? Let's estimate the total cost here. Let's estimate the total cost here. What will be our total cost? You can give it to the nearest whole number. What is our total cost here? This is the cost function, Y equal to A. So basically they are telling us what will be the value of Y when X is equal to 56. Si uko na kila kitu kwa cost function, you only lack X. So what will be the total cost? What will be our total cost? What will be the value of Y? What will be the value of Y? What will be the value of Y? The value of Y will be equivalent to, the value of Y will be equivalent to times 56. So what are we getting? What are we getting? What are we getting there? This is our total. This is the total cost. This is the total. This is the total cost. This is the total cost when activity level is 56. When activity level is 56. So is it clear to somebody now? Is it clear to somebody now? Is it possible for us now to use ILO method to come up with the cost function? Is it possible for us now to use ILO method to come up with the cost function? Is it possible for us to come up with the cost function using ILO method? Good. Don't delete what we've been able to calculate. Just bring in additional columns here, because I want us to compare this. Now that we have X column and Y column, are we able to get the slope? Because our interest here is to get the slope and also intercept, right? So come here, our cost function is equal to Y. Let me remind you of the cost function. Y equal to A plus B X. So whatever we are lacking here for us to come up with the cost function is basically the value of A and the value of B. The value of A is the slope of the curve. The value of the value of A is the intercept. The value of A is the intercept. The value of B is the slope. So let's come and type the word slope. We want to use function within Excel that is called slope as a function. So when you type the word slope, first of all, it requests you to bring in the known Y. So the values of Y are these ones here, comma. The values of X are these ones here. Then you enter. When you enter, what are you getting? To 3 decimal places. What are you getting? To 4. Let's put it to 4 decimal places. Sasa mtu analia na hiyo ni just a function. Wacha tutoe hiyo. Equal to slope. So type the word slope. Known values of Y are these ones here, comma. Known values of X are these ones here. Then you close the bracket. If that is done, what are we getting as the cost function? The slope, that is the value of B. The value of B is 96 point. Let me put it to 4 decimal places. Now, before even we proceed, are you able to tell me the reason why we are getting 96, yet using ILO method, we were getting 109.0909? Can someone tell us if you have an int? Is there anyone who is able to give us an int? Remember, yes, ILO method, we looked for the highest values pair. This one here, we picked this. So let's say I want to pick that. Let's say I want to pick this, the highest values pair, and of course the lowest values pair. So let's bring the two here. We know these are the known values of X. These are the known values of Y. One of the limitations of ILO method is that it is discriminative. Thank you. That is it. It is not using all the observations, and there's high chances you'll be using the outliers. Let's say this highest amount was experienced during COVID when we had crisis, or this one here was used when they went for cheap labor, or there was lack of the usual labor. So this one cannot be used as a determinant, since there's high chances of you picking the outliers, the extreme lowest value or the extreme highest value, right? Now, let's assume these are the only observations because we picked these ones here. Are we able to use the slope function to arrive at the value of B? Let's see the value of B. Let's get the value of B equal to slope. Known values of Y are these ones here, comma. Known values of X are these ones here. If that is done, what are you getting as the slope? What are you getting as the slope? So it has actually confirmed what Paul has indicated there, that using ILO method, we don't use all the observations. We only selected the highest values, and of course, it is discriminatory, right? By doing that, when we only use these two figures and use the same function, we'll be able to arrive at this answer, right? So that is what we do. So ikishindikana na ile formula, you come and apply this. But remember, if you use the function, this slope function, you are not doing what they want you to do. Because if you use that, you'll be picking all the figures, unless you select first of all the ILO method. I mean the highest figures pair. If you do it this way, and then use the slope function, you'll have the correct answer. But if you combine everything, you are not using ILO method. You've used all the figures. Good. How about now that we've been able to calculate the value of B, we need A. How will we be able to calculate A? A, we said, is the y-intercept, right? So let's come here and type the word intercept. Intercept. Intercept, so type the word intercept, 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 non-values of y, non-values of x. Let's start with the entire data set. So non-values of y are these ones here, comma. Non-values of x are these ones here. We don't include the title. Why are we not including the title? This function does not give us the option of indicating that we have the title as the first row. So don't include the title here. So when you close the bracket, what are we getting? Intercept. What are we getting as the intercept? 17. So this one here is supposed to be next to that. But if you want to get, so using these two items only, let me bring my B here equal to, let me bring my B equal to slope, non-values of y, non-values of x. If we use just this data set for us to be able to get slope, I mean intercept, which is A, what will you have? Intercept. If you want to get non-values of y, non-values of x. Are we getting the same thing as what we are having the other side? Are we getting the same thing as what we had the other side? Are we getting the same thing? Good. So I believe you've been able to see how this one is coming out clearly when you use ILO method, and of course, when you use the other function. So ILO method, the only thing you need to consider is have the pairs of the highest values and the lowest values. Once that is done, you are free to use this particular function for you to be able to solve this. So I believe the key areas under ILO method, we've been able to cover them, and that marks the end of the ILO method concept. Good. But now I want us to proceed still before we get to regression. Our interest is getting the cost function. So it will still give us the cost function in the form of y equal to A. We have A here, 436.3636 plus 109.0909 x. That is the cost function. Don't delete anything, just create space. Just create space there. I want us to solve the same using scattered graph method. I want us to solve this using scattered graph method. By default, if you're going to draw the scattered graph method, you will be coming up with the values of x, y, x, y. And if you have x, y, please go back to the intercept. Wow. Intercept iko hapa. Intercept iko hapa ndio hii. This is the intercept. Our intercept, we pick the non-values of y. These are the values of y, comma, non-values of x, we pick these ones here. And then you enter. Is it clear now, Lydia? Is it clear now? Are you working with the two numbers? Yes. We are working with the, I add that. You have that because you've used all the moment you use all the data, you use all the observations, look at what I'm having as the range. The moment you use all of them, You are not using high-low method. High-low method requires you to identify the highest value here and the lowest value. Why are we not using our new figures for the function for the second method? The new figures, we've been able to use that. Our new figures are these ones here. Look at it. These ones here, intercept. We used these two and this one here. The value of B, we used this and this one here. Is it clear? Is it clear? Mercy, Lena. The function y is equal to a plus bx. Oh, here, the reason why I'm not interested in coming up with this, it is not under high-low method. So what you need to do is, what of this one here, Nigani? This one is not high-low method. This one here is what we call regression. This one here is regression, in regression. So for intercept, are we to use all the values or the highest and the lowest? If the examiner said use the highest value, use the highest value and the lowest values pairs. Intercept is the same for both methods. Intercept is the same for both methods. No? This one here, remember, watu wanasahau kitu hapo kidogo, wacha niwaonyeshe. Look at what I'm having here. If I try to edit this formula, it is using all the numbers. We are using all the numbers here. We are using all of them, but we only need two, the highest values and the lowest values. So E method, I was trying to explain to you why, if you just use the slope function and intercept function blindly, we'll be getting zeros, is because if you use it, you're going to use all the figures. But when the moment you use all the figures, you've used the average numbers, and that is not high-low method. That is now the regression. That is the regression method. So the first way of getting regression method or getting cost function using regression method is by doing the getting slope, getting the intercept. So our cost function using regression method is y equal to A, which is 17.7343 plus 96.3514x. So this is the cost function using regression method. So the first way of doing or solving, coming up with the cost function using regression method is this one. This is the simplified one. But remember the limitations of this method. You will not get what we call ANOVA. You will not be able to get what we call ANOVA, right? You will not be able to get what we call ANOVA. You will not be able to get what we call the intercept. Intercepts at 95% confidence level. The lower and the upper, you'll not be able to get them when you use this simplified function to come up with the cost function. When you use this slope and intercept function, you'll not be able to get ANOVA and also the intercepts, right? So this just help they get the cost function. What if we use lightness to get the gradient? We are actually getting to that point. We are getting to that point. That was my next move. What is ANOVA? Analysis of variances. Analysis of variances. Good. So let's get to the next question that NG, or the next concept that NG is asking about. Is it advisable to go straight to the Excel function when asked high-low method? Why not? So long as you're able to identify the main problem or the challenge here, the main step is to identify the highest values and the lowest values pairs. Once that is done, arriving at the answer is now by use of any other method. You can use it manually, which we did there, and of course also use the functions here to arrive. You are able to see the final answer is the same. So long as you're able to identify the lowest and the highest values pairs, right? If you use all the values, you are now doing regression. But then this one will not give you the analysis of variances summary. So let's come to this part. We want to do, let me do the high-low method. regression, this is the data set. We want to use scattered graph for us to be able to come up with the cost function. So just get to insert. Then we'll be talking about the scattered graph. So come and highlight this data set. Come and highlight this. Come and highlight these two. By default, the first column of the highlighted data will be taken to the x-axis. And that's our interest. So that's why we start with the x values, then y values. So once that is done, highlight it, go to insert, come to this part. Pick any of the numbers that you'd like to do. So look at what we have here. Look at what we have here. Our data is scary, right? So if you look at what I have here, so look at it. Let's pick the first one, or even the complete one, or even this. Look at how it is appearing. That is what we have. So that's the scattered. That is the scattered graph. That's the scattered graph. So having indicated the scattered graph, so look at how scattered graph is going to give you another method here. So you come to this part and get to the trend line. So trend line here, you get to the trend line. It is linear. So you take that, it is linear. Once you pick the linear part, you move to more options. So you come here to the trend line, linear here, then you go to more options. Once you get to more options, just scroll it down. You are required to draw. So one, set, intercept, or display equation. Actually, it's display equation on the chart. So the moment you display equation on the chart, what are you able to see? Please tell me what you're able to see in reference to what we've been doing. Is it close to anything that you calculated somewhere? Is it close to anything that you calculated somewhere? Is it close to anything that you calculated somewhere? Let me know, let me know, let me know. Is it close to anything that you calculated? So you don't need to start mastering the slope function. Just draw the scattered graph. And then you say display function. And automatically you get the cost function. Mtu amepotea, mtu ashapotea. Wow. Sasa wacha tutafute wenye wamepotea. Wacha tutafute wenye wamepotea kwanza. Good. So we are at this point. So do we all have this data set? Do we all have this data set? This is the starting point. Do we all have this? Do you all have this with us? In your computer, uko na kitu kama hii. Now, highlight the whole of it. Highlight the whole of it. Go to insert. Go to insert. Scatter. And then you pick this first one. Once you click on that, imeleta hii. That's the second step. So, do we all have this? Do we all have this? Do we all have this with us? Do we all have this with us? Good. Just click on any part of this for you to be able to see these three displays. So this one here is to filter. This one here is to bring in the chart styles. And of course, this one here is to display the chart elements. So go to the chart elements, click on it. When you click on the chart elements, you'll be able to see the items listed here. So number one, which you should not forget at any given time, is the axis titles. Those are 3 marks unapewa hapo. Good. Another thing, we move down now to what we call trend line. When you click on trend line, this one here, click on this arrow, it will display another thing. It is linear, yes. So that's the first thing, it is linear. For you to be able to see this displayed, this one here, line of best fit. Having done that, we now move to more options. Tuteremke hapa chini, more options. It displays this. We've confirmed it is linear. Then you just move to the very last part of it. You tell it, display equation on the chart. When equation is displayed, this is the cost function. Y is equal to A plus BX. So our B is 96.351. Our A is 1717.7. That's how you do it. Wow. Why can't we do the same to this now that we have X and Y? Yes, we have known values of X and Y. So why can't we do it to this? Highlight this, go to insert, scatter, pick this, right? Oh, I've picked the wrong one. Highlight this X, Y. Yes, that's what we have. So go to insert, scattered. We pick this one here. Then you go to this part, trend line, more options. Sorry, it's here, trend line. Oh, we have series 1 and 2. Good. So if you look at what I have here, it has interchanged. There's a problem. There's a problem. There's a problem. I've been able to see that. The known values of X, this one will be taken to the X coordinate, and this one will be taken to the Y. So as you can see, we only have 2 of them, right? We only have 2 of them. There's a question here. I am able to name the axis. Wow. How now? How now? If you highlight this, you come to this part of insert. Now work AV. If you come to this part, now work AV. If you come to this part, let's just do this. How do we name the axis? Unakuja tu hapa. Just come to this part. Are you able to see this? Come to this part. Axis. Ndio ukiweka tu titles, access titles, inakuja hapo. Inakupatia hapa access title. Y x-axis. What have you placed in the y-axis? What have you placed in the x-axis? And what is the title of the chart? Si hivyo. Then unakuja hapa hivi trend line. Then unakuja hapa kwa more. Then you give us series 1. Okay, let's say you've picked series 1. Then you come down here and you pick display it there. That's what we have as series 1. Okay, come down here, trend line, more options, move down, then display a question on the chart. Good. So are we able to see something there? Are we able to see something there? These options do not come on my graph. Lazima zikuje, haziwezi kosa kuja. You must, there is something that you are not doing. Wacha sasa tukusaidia. You cannot get them when you just place your cursor on any other part. You just place your cursor on that chart for you to be able to see it displayed here. Lazima ikue, lazima. Unless you are using the oldest Excel version. Kama uko na oldest Excel version, tafuta 2021. Tafuta 2021. Tafuta 2021. Is that clear? Is that clear to somebody now? Is that clear to somebody? Nimekwama hapo kwa series 1. Hakuna option ya linear mwalimu. Hauja select linear. Okay, please follow that. follow that. Okay, my interest not even you having this one here displayed in the chart because we only have 2 points. Are you able to draw it using the other method? Let me do away with this one here. Are you able to do it using this? Are you able to do it using the other one here? Linus, are you able to do it using this other set? Are you able to do it using this other one? Hii hapa. Are you able to do it? Then you are good to go. Hilo method tunatumia ile formula. Hii ingine tunakuja hapa. Your graph in calculate automatic. I'm getting straight line on the second graph. Yes. Yeah, that equals how good. Don't be worried about that. So long as you know how to deal with this. And imagine they are going to tell you to display R. Okay, because we have 2 data points. That's where the limitation is. We have 2 data points. You should have at least 3. You should have at least 3. Sasa, I want us to draw the same thing, follow the same procedure I want us to draw, but this time round, we also display R. We also display R. Let us display R. Insert, scattered. Let's pick this one here. Go to this part. Sorry. Go to this part. We go to, let me make it down here, somewhere here. Yes. So we go to this part, trend line. Click on more. Bring it down here. Number one, just do the same thing that we did. So number one, display question on the chart. Number two, display R squared value on chart. R squared value on chart. So those who did advanced management accounting, you're able to remember they were telling you that 32.48% changes in labor hours are explained, or 32.48% of the total cost are actually affected by labor hours. The difference between 32.48 and 100 are explained by other variables which are not under consideration. Lakini sasa hiyo haikuja hapa kwa BDA. Hiyo explanation wachana nayo tu. Why are you not speaking linear options? Si tuko na linear hapa jamani. Tuko na linear hapa, trend line. More options. By default, unaona imepick linear. If I want exponential, this is what I have. If I want logarithm, this is how it is going to appear. So we are using linear. By default, it is picking linear. Aya, mwenye anasema rudia on R. Are you at this point? Enda hapa chini uone R penye iko. Ndio hii. Display R squared value on chart. Are you able to see the value of R? Are you able to see R here? Just mark this box. Doris, just ensure that this box is marked. Na utaona R inakuwa displayed hapa. R squared. Good. That is it. So that's how you get. That's how to get to this. And I believe they asked about getting R squared on the chart. If I'm not wrong, let me see. So we've actually answered, Roman 1 indirectly. Plot a line graph for price against time, stroke dates, insert linear trend, displaying the question, and R squared on the chart. So are you able to answer Roman part A of the question? You're actually doing A indirectly. Can also click on that trend line to get the question and R square. My R square is different from yours. It means you use different figures. Kama isio the same. Hiyo 214 marks. Ni hivyo tu, imagine. Una vile ni rahisi. Hivyo tu, and you have your 14 marks. A question is the same. I hope your R square hatuambiwi to calculate bila graph. Hiyo unachora tu hapa kwa graph to just display it. You just display it here. So are you able to do A? Are you able to do part A of the question? If yes, what is the value of R? What are you getting as the value of R for question number 22, April? What are you getting as the value of R? You want us to do an illustration and then get to the question. Illustration and then we get to the question. Repeat on the linear on the last graph. So tumesema una click to on that linear. To briefly discuss your results. Sasa hiyo R square ndio nasema una explain to them. What are you getting? Mtu anasema 0.3248. Hiyo ni ya this one here, ya the data set. Nataka uniambie ya ya question number 22 of April 2023. Are you able to give us the value of R square? So number one, look at what they want us to draw. Plot a line graph for price against time. Do we have price? Do we have price against time? Do we have price against time? Price ndio hii na time ndio hii hapa hivi, right? So if you have price against time, price against time, price against time, price will be in the y-axis, right? And the time will be in the x-axis. So the arrangement here is okay, right? The arrangement here is The arrangement here is okay. But we are not interested in using the production in kgs. Are you able to draw the chart, and then at the end of it, you do away with this one here, you select the data set? Are you able to do it? Yeah, the first method najua mtu ataniambia tunafanya hivi. What is it in x-axis? What have they said? Draw. Plot a line graph for price against. Price against. It is y against. Price against date stroke time. So which one will be in the x-axis? Which one will we have in the x-axis? Which one will we have in the x-axis? Date, right? So date ndio hii hapa hivi inakuja ya kwanza, so that is okay. Then this one here inakuja ya mwisho. So just come and draw this. Having selected that, you go to insert. Let's go to insert. Insert. Which one do you want to grow? Which one do you want to draw? This one here. Okay, you can go with this one here, or even just have the scatters. But now you want to filter out. You don't need production. We only need time. Oh, it has picked. So let's pick the data range. So just come here and select data. So which one do you want to pick? We've been able to select that. We want to get it time. Time will be there in x-axis, and then our interest here is not. We are not interested in production. We are not interested in production. So we just select the data. So having selected the data in that particular manner, what are you going to do? You come to this part, trend, more options. Then you come to down here, display. We have the option of displaying it here. We've selected wrong data, right? So if you look at it in that manner, you'll be able to see you're having issues with it. So there is no harm of doing this. If you're not advanced in data, you'll be having an issue. So what you need to do is, why can't you extract this other part? Because you are answering number one, part A of the question. Have your date, have this extracted, to this part, and then you do away with the production. So once that is done, you are now remaining with the two, date and prices. So that is what you have. Then come and draw. So insert, scattered, then you draw it in this manner. So if that is done, so do we have the date indicated down here? Yes, and of course the prices are actually there. So you can even draw, you can decide to pick whichever design you want, but you can now come and display it here. Let's come and display it here. Let's come and display trend line. So that's the first thing. Then once you draw the trend line, you come to more. Then you display question on the chart. We've been able to display question and also display R squared value on the chart. Then you minimize this. So you can, as you can see, the data set is so huge, you can just expand it. Let's try to expand and see it together. And of course, the trend line, we can make it to be a smooth one. I just want to display this one here. Will it be big enough for you to be able to see? Let me make it bold enough. Is there anyone who gave us 0.4133? Is there anyone who gave us 0.4133? Is there anyone who gave us 0.4133? Anybody who gave us that? Anybody who gave us that figure? So the cost function, or the function here, is y equal to, remember, you're able to see we have a negative. So negative 953.18. Yes, plus 0.0287x, r square 0.4133. So look at the items we are preparing here. We are comparing date and the prices here. Yes, the prices will be affected by date to some extent. Basically, we are referring to maybe exchange rates. These exchange rates are changing with the time due to some other economic factors. But date does not directly affect the selling price. So if you look at it, the data set here is clearly telling us that the changes, remember, price is in the y-axis. So price is the dependent variable, right? According to the output here, price is provided in the y-axis and it is the dependent variable. So when you are now explaining to us the value of R squared, you are telling us that the changes in price, or 41.33% changes in the selling price, are explained or affected by the date. While the difference, the other percentage, we are talking about 1 minus 0.4133. We're talking about, so let me make it huge figure here as a percentage to 2 decimal places. So this one is the same as, also let's have this one here also. Then we have equal to 1 minus this for us to get the percentage. So we have 41.33% changes in the selling price are explained by the dates, when 58.67 changes in the selling price are explained or affected by other factors which are not under consideration. So you are now explaining to us the R squared. So it is only 41.33% variables or changes in the selling price which are affected by the date. The remaining 58.67 are explained by other factors which are not under consideration. And therefore, it confirms that this output here is not statistically significant. It is not statistically significant. And then you are done with part A of the question. So you remember, you have to give us the title. You have to give us the access title. You have to give us, again, the titles here, both X, Y axis, and the title of the chart. Then you display this as per the instructions, and you'll be able to have your 14 marks. Nivo 2. Why did we filter price? Why did we filter price? Price tulifilter kweli? Tulitoa hii. I think this is what we tried to filter out, but it was not working out. Which scatter did you choose? Kindly repeat the statistical importance. How did you enlarge the R square? Oh, mtu ameshindwa kuenlarge hii. Mtu ameshindwa kuenlarge. Sasa hii tunaweka hivi. Just come and place your cursor. Just highlight this, then you select all. Then you come to home. Ukikuja hapa kwa home, you'll be able to expand it. Sasa you'll be able to reduce it kidogo, ama uweke hapa hivi kae kubwa hivi. Mambo na titles, we only tick. Yes, you only tick, alafu you write now the actual. Write that explanation. When? Okay. 41.33% changes in the selling price are explained by changes in date, while 58.67% changes in the selling price are explained or affected by other variables which are not under consideration, making this output to be statistically insignificant. How did it tell the significance of the model? Because only 41.33% are actually true, are the ones that are affected. The changes in selling price here should be affected either at least 100%, it should be 100% affected by the variable under consideration, but only 41.33, less than a half. Ikifika 50 plus 1, jua tu hiyo iko statistically significant. But if it is less than 50, it is statistically insignificant. it is statistically insignificant. Sio iko sawa sasa? The question was draw a line graph, but we have used a scattered graph. Are they the same? Okay, let's do that. Let's do that to remember, this is what will be happening. If you draw a line graph, you are going to have two different data sets, right? The line graph is not used to have X and Y axis, but when you're going to come up with the R squared, the cost function, it means we're going to explain two cost functions, right? So which one will be X, which one will be Y? Which one will be X, which one will be Y? Which one will you have as X and Y? Which one will be X and which one will be Y? Remember, line graph will not give you the X values and the Y values. So it will be using a default figure. It will be giving you 1, 2, 3 up to the last figure to be the X. This is what you are going to have actually. Let me just draw it for you. Tuone hapa. If you try to draw a line, if you try to just draw a line, this is what you are going to have. If you try to draw a line, let's see if you're going to have the same thing. If you're going to have the same thing, we expect that to be in the Y. We expect that to be the Y axis. So we can even use the forecasting again. So this is what you are going to have. Then from this point, you can give us the line of best fit. You can give us the line of best fit by coming here. We'll be able to arrive at the same thing. Let's see, let's compare the two. So you come here and give us the trend line, which is there. This trend line, we want to make it to be. So you come here to more. Let's have that. Let's have that. So display equation on the graph and then R square. Then we compare. So I want us to compare the two. Someone was concerned. So let's compare the two. Let's compare the two. Do we have the same thing? Let me display all of it. Are we arriving at the same thing? Are we arriving at the same thing? Tuangalie vizuri. Are we arriving at the same thing? Are we arriving at the same thing? Then you tell me, I've decided to use this. I've decided to use this. Let me bring it to this side. If I have decided to have this now, then I come to the chart design. I want to use the complete lines. So here, you come and use the complete dash type. You want to use that. That it can be visible. It can be visible. It can be visible. Good. Are we arriving at the same thing? How do I change Y and X axis? What do you mean by change? Although the examiner stated, are we getting the same thing? Are we getting the same thing? Are we together up to that point? Are we together up to that point? Are we together up to that point? Now, we've been able to use what we call R getting. Sasa kuna kitu umekosea hapo hivyo, because the figures are actually giving us the same thing. Now, using a suitable Microsoft Excel function, show that the coefficient shown in the trend line in A above are, in fact, the results of the linear estimation between the historical prices and time. So we want to look at price and time. We want to look at price and time. We want to look at price and time. So in short, I want us to use now that Excel function. Mama, ile Excel function. Just click on that, then you delete, utakuwa umeitoa. I want us to use this for us to be able to come up with the value of the cost function in the form of y equal to a plus bx. I want us to use that. So the first thing we need to do, we identify x. Which one will be x? Which one will be x? Is it date or price per kg? Tulisema date ndio x, right? Tulisema date ndio x. Na tukasema price ni y. So price is dependent. Price is dependent on that. So let's come and get the value of b. B is the slope of the curve. How do we get slope? Slope with known values of y. So using your known values of y, comma, known values of x ndio hizi hapa. Known values of x ndio hizo hapo. Then you close the bracket. Ukifanya hivyo, that's the value of b. How about value of a? A is the intercept. Known values of y ndio hizi hapa. Comma, known values of x ndio hizi hapa. If that is done, we'll be able to get this. Are they close to what you are getting using the graph? Are they close to what you are getting using the graph? Are they close to what you are getting using the graph? So they want you to use the Excel functions. Here tumetumia tukapata. We are basically confirming. So they have decided to tell you to confirm if what you are getting using the line graph is the same as what you're going to get using the another Excel function. So remember, slope is a function, intercept is a function, right? Are they clear to somebody? Are they clear to somebody? Are they clear? Mtu ameshindwa. Sasa mtu ameshindwa. Which part are you not getting, Brenda? Which part are you not getting? Oh, good. Now, that is method 1, method 2. We've been able to use the 2 actually since we started this class. I want to introduce the third one. So highlight the all of this data or just go to insert. Rudia. Which part? Using this function or wacha turudie. B is the slope equal to slope. Known values of y, una select these values of y, comma, known values of x, una select. Remember here you don't include the title. So kama imeselect title, unairudisha inaanzia the exact data. Ukiweka hivyo unapata hii. Intercept equal to intercept. Known values of y, tuna select hizi. Comma, known values of x, tuna select hizi. Unaeka, then we get it. So that's how we arrive at that figure. Sasa tunataka kutumia ingine. Go to data. Let's go to data. Once you get to data, there's this part called data analysis. Once you get to data, go to data analysis. And of course, what we've been using here is the average. So another name of that average method is what we call regression. So look for regression here. Look for regression, then you confirm. Input y range. So it is only this method that allows you to include the title. Why? It provides an option of telling the Excel that the first row of what you've selected entails the title of that data, right? So you come here and tell it, input y range, include the title. Input the y range, then you include the title. Then input x range. Highlight the all of it, including the title. But now when you come down here, inform your Excel that the first row of what you've selected entails the title of the data set. Confidence level. Remember they mentioned something to do with the confidence level. The default one is 95%. So even if you decide to put 80% as the confidence level, at the end of the day, 95% will also be displayed, right? So let's use 95%, which is the default one. Output range. Do you want it to be in a new worksheet or the same worksheet? I want it to be in the same worksheet. And where do you want it to be displayed? Let the results be displayed from this point. Then you confirm. Tukifanya hivyo, I want us to do comparison. So tunakuja hapa, remember what they wanted you to do in December 20, is it December or August? December 2023. December 2023. So one, they wanted you to give us regression statistics. So this is the first part, regression statistics. This is where we are getting. Are you able to see the value of R square? Is it the same as what we are having here? R square, R square. Are you able to see R square anywhere? R square. Are you able to see R square anywhere? Ndio hii hapa. The same as what we are getting the other side. Then ANOVA, analysis of variances. We have regression, these ones here. Analysis of variances. Analysis of variances. Don't have that analysis. Where? Okay, coefficients. The section of coefficients. Ndio hii hapa hivi. Intercept. Unakumbuka ile term intercept. When x is equal to 0, what is the value of y? This is now the value of a. X, this is the slope of the curve, 0.02874. So that's what you are required to do. Now, umeona ime display 95% confidence level, upper level and lower level. R square inamaanisha nini? Tume explain hapo hivi tukasema R square is basically how is the independent variable affecting the dependent variable. Our independent variable, which is the date, is affecting price to an extent of 41.32%. That is the changes. The changes in selling price are affected by date to an extent of 41.32%. The remaining percentage represent changes which are done or effects which are done by other variables outside the data model, which is not price, which is not date or time. Repeat on regression. Sawa. Now, I want us to repeat on regression. Unakuja hapa, go to data analysis, regression, confirm. I want to select the Y input. Select this is the Y input. I want to select X input. This is the X input. Then I want it to confirm that I've selected the title. So you mark that box. Confidence level. Let's this time round use 80%. 80% as the confidence level. 80%. 80%. Then output range tuweke hapa chini. Output range tuweke slightly below this. Somewhere here. That's our output range. Then you confirm. Aya, tuangalie. So if you look at it in this manner, if you look at it, look at now that 85. My interest is on the 85%, 80%, which I've just inserted here. So confidence level by default, 95% will be displayed, whether you like it or not. It is the default one. But you do insert a different value, you'll be able to see it displayed, which is the output range. The output range is where do you want to display this? You just click any place that does not have data. Just click on any space. Or you can even take it to a new worksheet if you like to do so. You can take it to a new worksheet. So the intercepts ndio hizi ziko hapa. Then the lower 95%, upper 95%. Then ndio hii lower 80%, upper 80%. So I was just introducing that because this is now the key area of discussion. Where did we get the confidence levels? Where? Mtu hajaona confidence level anywhere tukikuja hapa. Hajaona confidence level. Ndio hii hapa. Unaona hii confidence level ndio hizi hapa tunaongelelea hii. Inakuja hapa. If I want output range, if you want it, you select where you want it to be displayed. You select anywhere here. Or you can go to new worksheet, apply. so that it will be taken to a new worksheet without anything. Na hiyo jina ya new worksheet ndio hapa sheet number 2 imekuwa displayed hapa. Are these things really making sense to somebody? Are they making sense? Are they making sense to somebody? Are they making sense to somebody? Without bringing in a lot of things during your free time before we meet in our tomorrow's class, why can't you attempt December 2022 and December 2023? How to eliminate the midline? Why do you select the 3? Why do you select the 3? If I want to even look at to copy, if I want to use this one, I don't even need, because it gives you the option of selecting what you want. We've known that date is the value of X and price is Y. So why do you select again production? Because your data here, data analysis regression is giving you the option of input Y range. Si Y yako ni, you select the all of it. Then input X range. X yako si ndio hii date. Where do you come into contact? Where are you coming into contact with the production in kgs? Nowhere, because it gives the option of selecting this column and this other column. So you don't need this. It is irrelevant. Na kuja hapa kwa labels, confidence, uchukue unataka. I can decide to put 85 this time round. Output, I want a new worksheet. Na tunafanya nini? Na tunasonga. Na ndio zinaletwa hapa in a new worksheet. Are we together as we end the session? Am I using a new laptop where my Excel has no data analysis table? Inafaa ikue, lazima ikue. Sasa enda hapa kwa file, enda hapa kwa file, enda hapa kwa file, enda hapa kwa file, more options, enda kwa file, more options, enda kwa file, more options, enda kwa file, more options, trust center, file, more options, sorry, file, more options, file, more options, file. Kumbe tuko wengi hatuna we. Na mmerevise regression kwa discussion group na mjai activate hiyo. Amjai activate hiyo regression. Amjai activate hiyo regression. Okay. So is it clear? Senda kwa more options. More options, then we get to more options, then we get to each part. More options, is it advanced or more options, then trust center? I think so. No. Yangu iko sasa, utasaidia watu waje. Yangu iko hapo. Go to advanced options. Mine is not displaying it. Kwani niliweka wapi? Let me see the next part. It should be somewhere here. Options. Yangu imefichwa wapi? Let's go to this part here. Good. So you get to this part. So get to this part. Nimeipata. Go to file, more options, add-ins. Then you get to this part of go. Na utafika hapa. Ukifika hapa, kuna hii, there's this part here, analysis toolpack, na kuna analysis toolpack VBA. Nataka umark the first one. Hizi zingine wachana nazo. Hizi zingine wachana nazo. Hizi zingine wachana nazo. Hizi zingine zote kama uko nazo wachana nazo. Ensure that this one is marked analysis toolpack, then you confirm. Ukifanya hivyo utaona imekuwa displayed hapa. You'll be able to see it displayed here. So ensure that you have it. Ujaribu kufanya analysis. Tukipatana kesho tuna repeat everything under regression, and then we solve the 3 sitting questions before we move to break-even point analysis. That marks the end of our today's discussion. Thanks for your time. Have a blessed night, and let's meet tomorrow.